everyone, I'm TJB Chris. Welcome to my little corner of the internet, or as I sometimes like to joke, the kids' table of YouTube. Kudos to those of you who found that at the end of my last video. Hope you enjoyed it. That was a little bit of Gemini AI-generated fun. I don't do a lot of AI-generated stuff around here. I don't need it to make me content, and I sure as hell don't need it to make my thumbnails, because why let AI half-ass a thumbnail when I'm perfectly capable of half-assing it myself? Anyway, this is part 6 in my series exploring 513, a look at the Memorex VIS. And this will be the last part in the mainline series. So what we're going to do tonight I think is a great cap for the series. That doesn't mean the end of the VIS on the channel. Doesn't mean we won't be exploring, but it does mean that this is going to be the end of the branded videos, and there will probably be some other content mixed in. And tonight is the best because we are going to play with the Unicorn Developer cards, the cards that Tandy made available to developers during the VIS's very short heyday. And these cards allow you to basically turn your desktop PC, the appropriate class, into a quasi-VIS, giving it VIS-capable hardware, and with correct software, using VIS hardware and software interrupts to be able to interact with that hardware. Basically turning your PC into a VIS so you could test your software, iterate in place, and not have to worry about getting the software over to VIS, either mastering disks, or using the serial loader card, or even having a VIS. You could always get to the VIS later, but get started now with a PC. And of course, we've looked at the cards before. I did a quick video on the unobtainium unicorn cards, and they are very much that. There are very few of these known to be in existence, and these cards are on loan from Tandy Showcase. So thanks again to Tandy Showcase for lending me these cards. We're finally going to get to the meat of this. Now tonight, we're going to install these cards in the best PC that I own for this task, my Tandy 3000 NL. You've seen the NL do a few cameos on the channel before, but you've never actually seen it featured. I've never done any deep dive onto it. So I'm going to do a brief overview of the machine and how I got mine, and then we'll get right into the cards and taking a look at setting everything up. So as you're seeing on your screen, the 3000 NL was released in the fall of 1988 and debuted in the 1989 catalog. Again, Radio Shack catalog years, very much like automotive years. 2026 starts in 2025 sometime, and Radio Shack worked the same way. Now this is a straight up plain Jane AT, the kind of AT that was like a lot of other IBM and IBM compatible systems. It didn't even come with a video card or operating system. You bought the machine, it came with a keyboard, 512K of RAM, and you added everything else you wanted on top, e.g. or VGA video cards, hard disks or not, operating system, MS-DOS or OS2, you kind of picked. And in fact, the 3000 NL is the last of the Tandy 3000 series. So I got this machine. I found it, of course, on eBay, but the price wasn't too bad. But the pictures did paint a pretty accurate picture of a machine in desperate need of help. While I've had worse and seen worse, this machine was very dirty. Its cover wasn't secured and clearly had some damage, and internally it looked like it needed a little help. When I got the machine, it definitely was a little interesting. It had a weird push button stuck out of one of the expansion slots in the back that was wired onto the PCB of the A drive, the 3.5-inch floppy drive. Still not sure what that's about, and the A drive still doesn't work right. But it also was really dirty, and the front bezel definitely had some damage, which I had to clean up. So I did the usual restoration therapy on it. I didn't cover it on the channel, but I guess that's therapy now, just taking a machine, cleaning it up, making it look and smell nice. Got that working again. I also bought myself an XT-CF with the XT IDE Universal BIOS, so I have a hard disk in here. May not be the most performant, but this is a 286, friends. And I also bought myself a Phoenix VGA card for video, so I could use any one of my existing Tandy monitors with it. I also had lying around a 101 key enhanced Tandy keyboard to round out the package. In addition to the XT IDE and the VGA card, I also found on eBay the 8 meg local bus memory expansion card that Tandy made for this. In addition to the expansion slots, there's a dedicated slot running at CPU bus speed or clock speed that allows you to upgrade to up to 8 megs of memory on that card at full speed. Otherwise, you can use the ISA slots in there to upgrade the memory. And as it stands, this machine did come with a 2 meg memory card that was a little flaky but did work, and upgraded it to a total of 2.5 megs, including the 512K that was on board. So now it's an 8 meg machine using exclusively the Tandy memory card and some ECC SIMs that I bought, 30-pin SIMs. So it is really decked out. And what makes it perfect for the VIS is this is a 10 megahertz 80286 processor, and that is only 2 megahertz away from the VIS's 12 megahertz. Now, of course, because this has an ISA bus and the VIS does not, there's going to be the ISA overhead and a little bit of a performance penalty versus the VIS. This does not have a CD-ROM drive. Maybe we'll address that later, maybe we won't. But it has everything necessary to run VIS software with relative parity to the actual hardware. So I think it's perfect. Everything else I have is either too fast or too slow. So now that we've talked a little bit about the Tandy 3000 NL, and we've talked about why I think it's the best and what we're going to do with it, let's take a look at each of the developer cards up close, because we've got some configuration we have to do on each of these cards in order to make them work. And now that we've switched to card view, I've got an overhead camera suspended by some rigging I just finally decided to invest in because, VS to gratification ratio, let's make it even harder to make videos by making more stuff to set up. Anyway, actually it's been kind of overdue. Move my mouse here. And I finally did invest in this. It'll be handy on the bench too. Anyway, if this is weird and wonky, I apologize. This camera is actually my GoPro, so if the white balance is off, it doesn't really have granular white balance controls, but it's a pinch. So anyway, so this here is the video card for the VIS, and it has, I don't know if you can see it, composite and S-video out. Yes, you can. And of course, I've got, the ROM BIOS. I've got a DAC here, and this is the same DAC as the Tandy Sensation and the VIS itself. And of course, I've got in here a jumper to configure it. There's only one, and the remaining support circuitry. I believe this little header on up here is a feature header to allow additional video capabilities, but I don't know that it was ever used. Taking a closer look, you see here we've got the jumper settings for the interrupt, and that's the only jumper on the card here. Now, I know on the 3000 NL I have 3 interrupts available that are completely available. I have 3, 5, and 7 because I've disabled the printer port, and that's where the printer port would be, IRQ7. I don't have COM2, so that would be IRQ3, and 5 is empty. So the only one we're going to have to deal with is 9. This does have the IRQ cascade. I can't remember if I can actually use that or not. I know that kind of cascades back to IRQ2, so we might give it a try and see if it works. If it doesn't, that's going to mean that one of the 4 cards isn't going to be necessarily functional in this, at least as it is, or at least not without taking another one out. Now that might not be a big deal, because when I get to the last card, you're going to kind of see why, so it may not even matter, at least not in this video. So anyway, I currently have this thing set for IRQ9. So as you can see, this video card has a ROM BIOS dated 6/18 of 1992, and this ROM BIOS should be VIS capable only, so it shouldn't have full-on VGA capabilities. And when we get this in the 3000 NL and we get it working, we're going to test that using the modes program that I demonstrated back in, what was it, part 4, where I did the application development. 4 or 5, I've lost track of the parts, it's been a while. Either way, the video where I did the app dev, I made the quick basic mode utility to try it out. We're going to try that out and see if we get the same kind of experience that we do with the VIS. And that also means that the text screen should be a graphic screen. So anyway, that's the card. I actually have it configured for the correct IRQ already, so we can move on to the next card. Next up, we have the combined Save It and CD-ROM interface card. Now, as I mentioned previously, the interface is a Mitsumi-ish card. I do actually have a Mitsumi drive interface for the old Mitsumi drives. Again, typical interfaces back then. They weren't, yes, I know they used IDC 40-pin connectors, but they were not IDE. There was Sony, Panasonic, and Mitsumi were the big ones, in addition to SCSI, but both of the first 3 aforementioned ones used a 40-pin connector, much like IDE drives do, but again, it's not IDE. This card has that connector, so it is a Mitsumi-like drive. I do actually have a Mitsumi drive floating around here, and I do have a spare VIS too, if that drive might work. So we may get to trying that. Whether we do that in this video or not, I'm not sure, but it is something I'd like to try. Either way, the card has configuration jumpers only for the CD-ROM. So the Save It cartridge itself does not have an interrupt or a DMA channel. I think it's port addressed, but I haven't completely verified that yet. And you can see here we have IRQ and DMA. Now, one interesting feature of Mitsumi CD-ROM interfaces is that the DMA is optional, and you can run them in PIO or programmed I/O mode if you simply take off the jumpers and use a driver that specifies PIO. So if we get to using the CD-ROM drive, and I think we're going to have issues with DMA channels, I can pop these jumpers and we should be able to use the card in PIO mode. If not, I do have the DMA driver. And taking a closer look at the jumpers, we can see that we're configured for interrupt 5, which I think I'm just going to leave. I believe, is that DMA 5? Now it's funny, it's got 2 there, and it's not exactly clear what they are, but both are 5, 6, and 7. So I believe that's going to be the DMA selection, and it's broken up. I've configured both to be the same. That's how I received the card, so I'm not going to change it because I assume that means it worked with whatever developer actually had it. And Interrupt 5, as I mentioned, is free on my Tandy 3000. And you saw this card demonstrated in my last video when I walked through the Save It card and used this in my 4833 LXT. So we know this card works. So sans the CD-ROM interface, it should be pretty straightforward to just put this thing in and try it out. Next up, we have the AdLib audio card. Now, this is a custom Tandy designed card to provide AdLib Gold audio in the same style as the VIS and also the Tandy Sensation. So it's AdLib Goldish. Now this, of course, has a custom DAC and a whole bunch of custom gals on it. I didn't mention those on the Save It card, but there's a bunch of those there too. And as you can see here, I think this will stay in focus. Move it there so you can see it. We've got a bunch of jacks here, and we've got a volume control. And if you look closely, you can see they just used a standard slot cover thing here for this. They didn't use a molded one made specifically for the card. Now again, this card provides ad-lib gold audio, including synthesizer and wavetable services, and should be accessible on the usual ad-lib gold ports, and of course interrupts and DMAs, as I'm going to configure them with the jumpers that we'll take a look at. Now additionally, the VIS BIOS, as I've mentioned previously, provides audio services. So if we configure the card correctly and we set up the VIS as GBIOS the same way, we should be able to get audio from this card via both the services and via the direct I/O ports. I'm going to imagine most applications just use direct I/O. I have not played enough with the Int15 handler for the card to be able to interact with it just yet. I've kind of taken a look at it, but this card and its mixer services should be available. Synth services are going to be a bit of an issue, but we'll cross that bridge when we get there, and I'll show you why when we get there. So that is the card. Let's take a closer look so we can configure those jumpers. And now close up, you can see here that we are configured for interrupt 5, so I'm not going to have to move that one. Kind of got lucky on these. They were stuck in place. I wonder if these cards were used in a 3000 NL. And then again here, the same style with what I believe to be the DMA jumpers, again set to 7 instead of 5 like the last card. And to reiterate, I don't have any documentation for these cards, and the silk screen isn't always consistent between the cards for representing IRQs and DMAs. So we're going to kind of guess here and see if we can get them to work. We may not get them to work offhand, or I might find out a little more as I go along. So we'll just play along and see what happens. But my hope is that when I get this into the 3000 NL, that when I run a VIS compatible application, maybe Space Nuts or something, that's probably a good one to test, I should be able to get audio from this card. And I have a very fun, not quite period correct, but close enough pair of Radio Shack computer speakers to go with it once we get this card plugged in. Now, taking a close look at the end of the jacks, or as I should say, the end of the card where the jacks are, you can see silk screened in. They tell us what all of the ports are. We have line mic and earphones, headphones, and the volume control, of course, controls the headphone jack. So that's pretty cool that they put that on the silk screen for us so we know what's what. And that's pretty much it. Again, we've got the same custom gals and such on here. You can see a bunch of them. There's one right here. And I've not dumped those yet. I haven't dumped the gals on all these cards because a lot of these have labels covering their part numbers. And I'd have to remove the labels, and I'm afraid I'm going to damage them, and they're not mine to damage. So that is the audio card. Now let's take a look at the last of the cards. And finally, we have the IR receiver card. Now this card is interesting. This card, of course, we see we're going to have to configure the interrupt on here. I'll show you that in a minute. Clearly says IR receiver on it, and if I look at the end here, make sure I can see it, these are the PS2 style ports. And this is interesting. Now this says it's an IR receiver, but what I don't know, and again we don't have any doc, is this a direct connect to an IR receiver? For example, could I take an IR receiving photodiode and hook it up to this thing? It's a 3-pin connection, right? I have a set of photodiodes and it connects, VSS, ground, and a data out. So whenever it receives infrared pulses along its, I just shook my hand in the camera there, within its frequency range, it will just pulse them out the data line. And the block diagram and a simple schematic for implementing those photodiodes for the data sheets for the ones that I have indicate a pull-up resistor between VSS and the data line. Now, that mentions, what, a 30K resistor? Now, interestingly enough, if I flip to the back of the card, you can see here that we do have resistors between what look to be probably one of the 5-volt data lines, but that's hard to say. And the other thing is, I did do a resistance measurement on these with a voltmeter, and they're 10K. Now, I realize the specific resistor will vary by circuit, and so the documentation data sheet that I read could very well just be, a sample circuit, and that was the resistance that was correct for that circuit. However, I don't really have a good way to know. There are also PS2 implementations that have pull-ups to clock and to the data lines, I believe. So I'm not sure how to do that. And of course, in a PS2 device, I'm pretty sure the device generates the clock back so that the receiving device knows how to sync with the data signal that's coming back. So, for example, a mouse will provide its own clock. So I can't even just go looking for a clock line necessarily, and that's if I'm understanding PS2 correctly, which admittedly, my understanding of PS2 is rudimentary at best. But either way, I do have some photodiodes, some IR receiving diodes. They are 3-pin. I could potentially try to see if I could connect them to 5 volts, if this is 5 volts, and connect the data line back. Now there is a single data line. Let me zoom in here. Now there is a data pin. I don't have anything to point with. You're going to have to deal with my stubby finger. Right in the middle of this resistor, you can see a trace coming out. It runs all the way over to these bodge wires here, which just happen to go to an IC on the other side of the card. And that happens to be this Zilog Z80E 08112 PSC. This is a little embedded microcontroller. It has 2K of ROM on it and 125 bytes of RAM, I think the datasheet said. So this is a program, write once, and then you can't write it again, but it's a nice little microcontroller for small industrial applications and low volume applications, which is exactly what this is. So what I don't know is are those pins that are on the back there, are they coming from the PS2 style ports to provide a direct data line from pulses from an IR diode, or is that just the data received from PS2? So I'm going to have to do a closer look at this thing, and because of the issue with interrupts, it may not even be an issue, because if I have to sacrifice one card, it'll be this one. Why? Because, well, if it is PS2, I don't have any wired hand controls to use with this. And even if it is PS2, if they had IR blasters for it, but they were PS2 interface. When I say PS2, I mean IBM PS2 keyboard, not PlayStation 2, for those of you wondering. Apparently Dr. Google and the AI robots can't figure that out. Because I typed it in and Google's AI slop kept coming on and talking about the PlayStation 2, and I'm like, no, not PS2. Anyway, I digress. There might have been a third dongle that Tandy added on to allow it to receive IR. I don't know. So depending on how the voltages play out when we get this thing in the computer, if it doesn't cause the machine to blow up, I may see if I can throw a voltmeter on there and see if I can at least get an idea of the voltages, how many pins are ground, what else is on there, and see if I can trace back any one of those other lines before I put it in the PC to something that might be clock adjacent. But barring that, there's not much else to do. Now this particular Zilog chip, I don't know if you can see it on the camera, I'll move this up. There are two variants of this chip. One is a crystal oscillated version, and that appears to be the version that is here. Okay, so now with all that in mind, oh wait, we have to configure the card. Let's do that. So here we are with the jumpers, and right now we're at E2, which is IRQ7. I can't do that. I believe I can use 3. Let me look at my other cards. 9, 5. Let's look at the audio card here, because now I've been jabbering so much I forgot. 7. 7. Okay, so I'm going to move you over to IRQ3. Pull this off. Come on. E9, E10. That's right. And there we are. Now we have E9, E10, IRQ3. So that I know is open. I don't have a COM2 in here, so I'm not going to run into any conflicts there. So if I can't get this to work, it's because of something else. Now, interesting other side note is the IR diodes I have. I don't know if they're the same exact wavelength as the VIS controller, so may or may not work anyway. But we'll cross that bridge if we get to it. And again, if I have interrupt problems, I'm going to move the video card from 9 to 3, and this IR blaster is going to come out, and that's going to be it for that until we can figure out what to do. Or what we'll have to do is sacrifice another card. The audio will have to come out, or something like that. I've got to leave the video in because that's going to be really important. I could probably nick the Save It card and the CD-ROM interface if I'm not worried about the Save It cards. So that's another option, but we're just going to have to play them as they lie. I think I have 4 8-bit slots in this machine, but I'm not quite sure. Anyway, all right, so now I think it's time to get these cards into my 3000 NL. Now we're not going to just jam them all in at once. I'm going to take the cover off the machine, and we're going to set these cards in. The first two I'm going to put in at once. I'm going to put the video card and the Save It card in at once because I'm pretty sure that I know the Save It card works. And I played with the video once standalone, and it did in fact function. So these should work. And this will give me the easiest way to diagnose whether or not I'm going to have problems with IRQ9 or not with the video card. So again, that'll let me know right away if I have to just punt the IR receiver. But we're going to start there. And of course, because of the way that the BIOS in the VIS's video card is, I figured this out, it can't coexist with the existing Phoenix VGA card that's in the machine now. So the Tandy VGM220 monitor, one of the worst monitors ever, and if you don't believe me, see this video by someone not me. No, it's V. Westlife's video, and you should totally check it out. I think he did the VGM225, but same difference. It's not great, but it's part of the experience. Anyway, we won't have to look at this VGM220 monitor and its less than stellar picture quality because we're going to get to use a television. So I'm going to get this thing apart. We're going to relocate my overhead camera so you can see exactly what I'm doing and what the inside of the 3000 NL looks like. Get a couple of cards in, hook up the television, and we're going to try it out. Okay, here we are. You're going to have to spare me the flicker. The LED lights in the room cause cameras to go nuts. I'm hoping once I get this white cover off the top of the 3000, that'll help. So let's just get these screws out now. And one of the things I did with this 3000 NL, it didn't have case screws. So I managed to go to my local big box hardware store, you know, one of the two major colors that seems to dominate the United States these days, and happened to find an exact matching machine screw that wasn't too long that kind of works. All right, cover slides toward the front, and then I have to be careful because the front bezel is repaired, so I don't want to put any pressure on it. There we go. I should be able to lift this off now and get it out of here. Okay, taking a closer look here, zooming in. This is the Tandy specific memory expansion board. Here, I'll just remove this real quick. You can take a look. 3000 NL people. This is actually also compatible with the 4000. So the early 4000 series, the original 4000, maybe the 4016 LX, things like that. You may be able to use it there, but this card does work with the 3000 early 4000 machines. Pretty sure you have to use ECC RAM in it. That's what I had to use. And again, this slot is, you can see, not ISA. Has to run, it runs at the CPU clock. So it's faster, but it's limited to 8 megs. So if you want to go to 16, you're going to need to use a regular ISA slot. I've got 2 empty slots. And then I've got here, this is the VGA card, which is going to come out to make way for the VIS card. This is my NIC, and I'm hoping to keep it because I want to be able to get all the VIS junk I've written onto here. Over from, you know, networks or file servers or Raspberry Pis or my 4833, what have you, since I don't have a CD-ROM drive in this quite yet. Now over here, these are 8-bit slots going on from here. There are 3 8-bit slots. This is my XTCF, and the card sticks out the back here via this little adapter, then this extra long IDE cable. And of course, on board here I've got these are 512K of memory and 2 256K SIMs. And the additional RAM, because the memory configuration on this is weird, you can upgrade it to 640K with some additional, what are they, 4464s, I think? I can't remember exactly, but yeah, it's that whole thing. So it's a little bit of an interesting memory combination in this machine. Anyway, we're here to talk about the VIS. So let me get a couple of the slot covers off. First, we're going to start with the VGA card. Oh, this is Philips. And we're going to remove that. And in its place, we're going to put the video card. And my hope here is that between the video card and the Save It, we will be able to get the television hooked up and make that work. Now, I'm sure some of you are yelling at your screen because I left the, man, this really got a grip on there. I love a good grip. Anyway, the machine's still plugged in. I do that so I have a ground surface. So I'm always grounded because this room is carpeted. So I'd like to be careful. I do have a ground strap, but I can also at least ground myself. And I'm going to remove one other slot cover. We're going to remove its neighbor. So of course, shove this in here. We have the video card. And again, I've got the S-video and composite outputs. Now I have this set for IRQ9. And we'll just see what happens. Again, if this doesn't work, I'm going to drop, oh, I can move this power connector. I'm going to pull this back out, and I'm going to screw it in. And then we will connect the television, see if the machine boots, if I get a BIOS screen, and then we'll go from there. Next up, we want the Save It card. And again, the Save It card, here it comes, not reflecting on you, just has the CD-ROM IRQs, but this is the Save It cartridge right there. This is the Mitsumi interface header. This I'm just going to drop into the slot next to it. And this should be fairly straightforward. Oh, you got to take the slot cover out, you dummy. Got all excited. Tell you, this is like Christmas. This one cable is insistent on being a butthead. Okay. And there we are. We have a, move this back. We now have a Save It cartridge interface, and Cyber card, and we've got the video card. Now I'm just looking here to see if it looks like everything's flush. Okay, it looks like it is. Like I said, video card is going to stay like it is in case I have to take it back out. And that's where we're going to stop for now. No oceans to boil here. So I'm going to get the television set up next to this so I can see what happens. I'll flip the video capture over to the video capture for S-Video, which is going to be connected to this VIS card, and we'll see if we get video when we power the thing up. I'm also going to have to grab my keyboard. All right, well, we got the 3000 NL keyboard is back, and the television is sitting right next to it. I didn't want to put it on top and put the cover on, because I might have to go in there. And of course, where the VIS, the TV was, all the expansion cards that are still left are. So there's nothing left to do to power this up. I should get an interesting graphics screen here. And it looks like, ooh, we've got something. Oh, that doesn't look right. We got some color problems. All right, off you go. Okay, so we're going to want to take a look. Let's adjust the jumper on the video card and not do 9, and that might make it better. It did start to come up, you could see, but that shouldn't have been blue or green there. All right, let's flip to the other camera, and let's just see if we can pull this out. Disconnect the cables here. Okay. All right, card out. Currently, again, we're going to make it 7. So I'm just going to pull the jumper off here carefully so don't bend the pins. And we're just going to put it on the next one over. That's on there, right? Okay, yeah. The camera's not focusing, but it's IRQ7. So let's put that in. Okay, let's try this again. New interrupt, powered up. And we've got some video. Now, something is clearly wrong. It starts the memory test, but then is it even alive? No. Okay. Something is clearly wrong. Power you off. All right, for the sake of the process of elimination, I'm going to pull out the Save It card and the network card, and we're going to start from 0. Because until these cards work, there's no point in having the network card in there, right? I'm going to hope I can leave the hard disk controller in there, because I kind of need that. We're going to pull out the Save It card first. Actually, maybe I'll just try that one first, and we'll go from there. All right, let's pull out the Save It cartridge. Okay, and you know what? Let's just give it a quick shot and see what we get. All right. I'm going to reseat this RAM card one more time because I screwed with it. So I just went down a rabbit hole because I messed with this. I'm going to be very unhappy. Okay, here we go. Power up one more time. It doesn't complain about no RAM, and it should be doing a BIOS beep. Just out of curiosity, I'll let it count up and see what it does. And then what I might do... Oh, you're not even watching this. I want to see... Sorry, you didn't see the screen there. Oh, no, it's a 64K and it's 0, so... Oh, something's up. Oh, no, it booted. Starting MS-DOS. Interesting. F5. Where's F5? So the machine is running M, 640K, 7168 XMS. Okay. That's interesting. It's actually kind of working, but that's not right. Just out of curiosity, I'm going to power this off. I'm going to disconnect the television. All right, here we go. So I'm going to be looking at my laptop here where OBS is to see if I get... Still shouldn't be doing that. All right, I think what we're going to have to do... This is why this happens this way, friends, because now we have ourselves a conundrum. So the only thing I can do is... Oh boy, try this in another machine, I guess. It is working. Let me just... On this machine, the memory count up in the BIOS copyright is not green. It shouldn't be anyway. But even more concerning is it doesn't really update right. Now maybe that's just a function of the BIOS in this machine, but the other problem here is if I connect the television back up, I mean, God only knows, it looks really horrid. Now, I've never seen the composite on this. Let me see if I can get a picture with my phone. I have a app that lets me take fairly decent pictures, but there, it's going to be coming up on your screen now. So the issue here is, from a capture device standpoint, it seems to be working. But from a functioning standpoint, the card does seem to be working, but from a TV standpoint, it doesn't seem to be. Now, everything beyond here seems to be functioning. I see the machine boots. It has the correct amount of memory. Yeah, so that's interesting. Really, really interesting that that's not a thing. I guess the problem now is I'm going to have to break out one of the other machines, disable the VGA BIOS, and see what it does. For what it's worth, I think Tandy Showcase's site says it too, but I know there's folks that say the 3000 NL was kind of a development platform for this. Admittedly, let's meet over at the G21, shall we? The other camera where you can see me better. I can turn this off. So admittedly, I've been a little skeptical that the 3000 is a development platform. Again, owing to the timeline of the 3000 earlier, and the fact that it was, you know, out in '88, and by the end of '89 it was pretty much gone. From a on-paper standpoint, like I said, it seems like the perfect fit for the VIS. It's a 286. But you wouldn't be writing your code on it. If you're compiling that code, you want it to go faster than a snail's pace. You'd want to use something like the 4833 LXT, a nice 486 over there, and that one's even better because it's boosted to 100 megahertz. But even a 33 or 66 megahertz 486 would go a long way. Even a higher end 386 probably would. And for testing your software, though, from a performance standpoint, the 3000 NL really was the last of the Tandys and fairly close to the VIS. That said, you'd have to get the software over there. I just put a CD-ROM drive in it. So I guess before I get too far sticking cards into this, I want to see what this video card does if I shove it in another machine. And admittedly, now I have to go back and look through the photos I took. I did stick this in one machine, in the 4833 once. Just when I got them, I had to play with something, and I just kind of shoved it in there and connected it to a capture device, and it worked. And but now I don't remember if it did the greeny thing on the post, the count up, or not. So let's do that. I got to pick a machine, and I think I've got one in here that'll do the trick if I can figure out how to disable the VGA BIOS. So rabbit holes, friends. This video is going to get somewhat long. All right, let's grab another machine. I'm in a new shirt. That must mean I'm doing my best impression of Sting and starting up a brand new day. Speaking of new shirts, or different shirts, this is my Super Nintendo Chalmers shirt. Hopefully the mic didn't go nuts there. Great shirt. Great episode of The Simpsons. So, well, Ralph Wiggum always had a good line or two in him. Anyway, I've been thinking about it, and the machine I'm going to use is the one that I know the video card works in, because I mentioned sticking it in there already. We're just going to go right back home to the 4833. Rather than break out any of the other machines, it's got 4 expansion slots in it, so I can fit all the cards. I know the machine works. It's got all my dev stuff on there, all my software, all the stuff I've written, so I don't have to schlep files around. So honestly, now that we know at least my 3000 NL doesn't seem to want to play nice with a video card, I'm just going to go with a 4833. So I'm going to leave the overhead rigging set up for this for now. The card cage in that's a little different, so it's not going to be as fun to look inside of, but we're going to get that over here, get the cover off, and I'm going to disable the video BIOS, and we'll slap the video card in there and see what happens. All right, and we've got our top-down view. If you've seen the video on the 4833 before, of course, this is my Frankenstein Tandy. It is actually the motherboard from a 425 SX-MT, one of the Omni Profile series machines toward the end of Tandy's time in the business, Frankensteined into the chassis of Tandy's 4833 LXT tower. If I ever find one of those machines for real, 4820, 4833, or 4866, I will pounce on that. It is one of my unicorns. That's why I bought this one. Anyway, first thing I have to do here is I have to disable the video BIOS, or the video circuitry, I mean, which will disable the video BIOS, I guess. And I do that by moving jumper J28, which is up in here. Can you see me? Yeah, okay. From 1 to 2 over 2 to 3, right? No, from 2 to 3 over to 1 to 2, yeah. So let's see, I got my little pick here, see if I can get this in there. There we are, that should disable the video BIOS. Okay, here comes the video board, and that's gonna be the first thing we do here. And I know as I'm putting this in, I know there's some of you are thinking, I jumped the gun, I should have kept sticking with the 3000 NL. Maybe it could have worked, if only, woulda, coulda, shoulda. But here's the thing, friends, you gotta do your best Kenny Rogers. Know when to hold them, know when to fold them, know when to walk away, and know when to run, right? I could either continue to going down the road of exploring the dev cards, or I could turn this into the why doesn't my Tandy 3000 NL like this particular card rabbit hole, and spend a bunch of time hacking at that. And my 3000 NL works, so I'm not really in a mood to screw with it too much, not especially when I know that I have this perfectly functioning machine in hand. I'm a little disappointed. I really wanted to be able to use the 3000 NL, but I had to choose to fish or cut bait, and we're cutting bait. So, but I did finally get to intro it on the channel, and if you'd like to see that video or that computer more formally, let me know. I might do something on it. I don't do a lot of book report style videos, you know that, but I could make an exception for the 3000. It's a really cool machine, and I know people say it's just an AT, but these machines all have their different character and kind of ethos to them, and I like experiencing them. All right, enough jabbering. Let's see. Let's hook up the S-video port. Okay, perfect. Ooh, that fits better. I'll say that. And my composite cable is going to have to go around the television the other way, and I'm getting my hairy arms all in the shot. This is what no sponsorships, no Patreons, and no memberships get you, friends. My nasty arm hair. Okay. Now, let's flip you over to the VIS. All right, back over here. I got to power on my television. And hopefully, you should get, I'm going to use this camera this time because the lighting's better. Ooh, and I'm going to burp into my mic. Hopefully, I can get this to power up and show a display. Here it comes. Do we have, come on. Okay, we got sync. Oh, yep, okay. You can see it. My TV still looks crappy. I was thinking about this last night. Part of the reason that may not look good is the Gryphon BIOS has the ability to handle interlaced displays. This is such an early ROM, it might start in a state that's not meant for, interlaced video. So I imagine that I might, once I get control of this, be able to kind of do something good here. I'm just going to do the normal startup and let it do its thing. And we have the CD-ROM drive, which I won't be using because it's on its side. The video does update slowly. Oof. Ouch. I mean, this isn't meant to be a... And this is, again, just like the VIS, this is, and you can see even the fonts don't render correctly for my extended character set for my menu. This is meant to be the VIS video board. There is no text mode. What you're looking at is just like on the VIS. This is a 640 by 400 display that is emulating a text screen. All right, so with this up, I have my modes utility. I'm going to do this because it'll go faster, and do dir, card, tests, utils, control, screen, there we are. Remember the screen utility from when I talked about VIS video modes and how some were and weren't supported? So I just made this thing really dumb, no sanity checking, take a number. It works a lot like the basic screen command. It sets the video mode to whatever number I give it, and it attempts to draw a drawing on the screen. So for example, if I go screen 10, there we go. And these are, I want to say this is using the quick basic screen codes, not the video screen codes. So mode 0D, what is that, 10, 11, 12, is not actually going to be screen 12 here necessarily. It's whatever the visual basic or quick basic screen modes are. Okay. Now, actually, one thing Dummy here did was on the VIS, because the keyboard isn't really a thing for quick basic keyboard routines, I made this utility so that you have to reboot the machine every time you want to run it. That's not going to play here. A lot of VGA cards, like by default, the one on this board and most other Tandy boards I have, doesn't even use the interrupt. Does it need it? Let's find out. Again, we're enjoying my arm and elbow. It's going to take the... Oh, geez. Apparently that's the strongest, bitiest jumper yet. Okay. I take the jumper off. It appears to work. We're going to try the video without the interrupt, because, I mean, that's a standard in PCs. It may break software. If things get janky later, I will revisit. But if I can do it without the interrupt, why chew up an interrupt when I don't have to, right? So, and again, to the screen thing, actually, I just realized. Oh, source, you dummy. Screen 0 is the text screen, and you can see it blows an illegal function call. That's interesting. On the VIS, it just blows up. Nothing happens, really, right? But this early BIOS, it actually explodes. That's really kind of interesting. Oh, it does let me return to the system. Okay. Wonderful. All right, now let's go actually put this cartridge, save it card in here. See, folks, aren't you glad I usually do my videos a little more put together? I'm all over the joint. Screw it. Okay. And I'm going to insert this here save it cartridge right into the back. I think I've got that the right way. Can't really see it on the camera there, but it is inserted. I guess I'll slide you this way. Oh, can't even see it. Case overhangs it. Okay, well, I tried. You'll have to believe me. Save it card's in there. All right, let's power it back up. And we're back at this camera again. I realize you see me looking down my ThinkPad with my OBS is sitting right here. And that's why I keep looking down there. All right. Now we have the Save It cartridge. I'm going to go and run my rcard.exe. I think I still have my file on there. If for some reason it doesn't work, I'll just run my W card, and it should be able to write the card. I'm just going to hit F5. We don't need to wait for the thing to boot. Now, the first thing we have to do, if you want to use any of the VIS hardware, VIS Int 15, ISRs, which are pretty much the way to access almost all the Tandy hardware, including the Save It cartridge, as we found out last time, you need to run GBIOS. Now, interestingly enough, this does say that it has synthesizer services, but if you look in the README doc that accompanies gbios.com, it says something like nada, zero, zilch, zippo, something like that, that it's not implemented. So I don't know whether or not it is. That means that we may get wavetable, but we may not get synth audio with VIS titles. So we're going to have to see how that goes. Anyway, now that GBIOS is loaded, source, VIS card, test. By the way, my scaffolding and duct tape save it crap is up on my GitHub now if you want to play with that. It is in fact scaffolding and duct tape. I don't write this code to be good. I write it just to see if I can make the thing do what I think that I can make the thing do. It really, oh, son of a bitch. It really just allows me to see if I'm understanding the hardware well enough to be able to make it do the thing it says it can. Yeah, this is not ideal. Okay, so let's do rcard. Failed to read card data. Okay. Success! Okay. So I did reformat the file. The failed to read data was because it didn't exist. My program's dumb enough. It just, if not good, bail out. It doesn't actually say, well, what's not good? It just kind of does. Okay. Excellent. I'm someone now. Hello, you rummy buzzard. All right, so now we have Save It cartridge. I did not recheck the interrupt on that. It should still be good. This machine, the only difference on this, and I think I disabled the parallel port, but if I didn't, I can. That might take a real monitor. Let's try. Can I F2 into setup and not have this video card freak the hell out? Tandy style setup programs are text-based, but if it doesn't actually flip the video mode, maybe I'll get lucky. Ooh, no. Hey, hey, it looks like ass, but it works. Okay. Parallel port. I got to get all the way down to the parallel port. COM1, COM2. Oop, go back up. Space. Disabled. Okay. And, we're going to turn off COM2, okay, as well. That way, you can actually disable the IRQ for the parallel port? Is that what that says? Yeah, you can. Okay. Interesting. Guess you could keep the parallel port and not have the interrupt. I don't need the parallel port. We're not printing today. F2. Cool. All right, well, I'm glad that worked. Took a chance on that. Like ABBA. Now my IRQ's free. Take a chance on me. All right. Just full of great references today. Why am I doing the memory tag? I'll finish anyway. Okay. So now that we're this far, we have two of the three known functional or should be functional cards in there. The ones I know I can work with, I should say. F5. Now I guess it's time to do the audio and see if we can get that in. And then once we do that, I think I'm going to try and run Commander Keen just to see if it starts. I'm going to run the VIS, the VIS version. The hand control is its own little mess. I don't have a wired hand controller. So if those are PS2 ports on that card, then I'm going to have to get clever. Okay, let's do that. A little less conversation, a little more action, please, right? I'm sure that's what you're yelling at your screens. Okay. Here comes the audio card. And once again, it is a full-length card. In fact, ooh, is it going to reach? Is it going to fit? It is. Oh my goodness, that's close. I just got to... Yep, okay, we're in, and we're safely in. Okay. Now, what's your interrupt? I know I can look back on the video. The synth doesn't actually have one. I can stick my head in. 7. Okay, 7. The synth doesn't have one. If I have to, I'll put a jumper on there. You probably will need it. Here we go. Gryphon audio system. I like that the board actually says it on it. Gryphon audio development system. Very cool. Powering up. Back over here. We're not going to F5 our way through startup. Okay. Yeah, so as much as I'm disappointed that I couldn't use the 3000 NL, at least my software is here. But I am pretty disappointed, and I don't have any other 3000s to play with. And the older 3000s, like the 3000 or the 3000 HL, are slower. So, and I don't have a 3000 HL. So, I'm not going to buy another 3000 NL. Hell, I had a hard enough time finding this one. So I don't want to buy another 3000 NL just to see. Maybe someday I'll go down the rabbit hole of seeing what the hell the issue is. Okay, so let's run GBIOS. Actually, there's some documentation that we need for GBIOS because it has switches. Otherwise, it makes assumptions about where the cards are. Okay, as you're seeing on your screen now, this is from 1992, and this says the Gryphon BIOS set of services. And actually, this is where I'll show you here. If I tell you what's implemented, here, this is my favorite. Synthesizer services. None, nothing, zilcho, nil, null, goose egg. No functions are implemented. More information and code updates will be provided. And this is for the 1.0 release, I believe. Yeah, 1.0. So I have some pre-release GBIOS versions as well. And some of those actually specifically call out in the text that comes up when you run GBIOS that it won't work. Anyway, you need to give it the wave audio, the hand control, and the DMA for the audio card. DMA 6. Okay. So here's what we're going to do. We're going to do GBIOS slash, what's the HI? Oh, I don't have the hand control in there, so I don't have to worry about that. So I just have to worry about WI equals, and it's the IRQ number, which is 7. I'm using DMA 7. Okay. 7. I'm sorry, this is going to be WD equals 7. Just out of curiosity, what if I run modular Windows? Yeah, it needs a different driver. I don't really want to set up the driver. All right, I'm not going to mess with Windows. Okay. All right, so one other thing I did add off camera is I have these fun Optimus speakers. These are absolutely horrid. They're from actually 2000, so they're not exactly period correct with the machine and the VIS, but they're close enough. They're from Radio Shack when it was still the lineage that Radio Shack was then. It even still says a division of Tandy Corporation on the back because it was right around the time they changed to Radio Shack Corporation. Anyway, these speakers sound like shit, but they are going to work, and they are connected to the earphone jack of the VIS, and I've torqued the volume control a little bit. It's a little crackly, so I might actually have to spray some contact cleaner in there or something just to kind of make it work a little better. So if we don't get audio to start, I will start there. Okay, I'm going to try Space Nuts, because Space Nuts actually should exercise, works with a keyboard. It should exercise the video and audio, so that should work. It doesn't use the Save It card, but I don't really care. We already know that works. All right, let's see if this is enough to run it. Thought it was Space Nut. Oh, it's starting. Gryphon audio BIOS not detected. Oh, you're an idiot. GBIOS slash WI equals 7 slash WD equals 7. I wonder if that means it actually uses the interrupt services and doesn't just detect the adlib card. Because in the VIS, you don't have to use the services. It's the standard adlib addresses and interrupts are there. But not here. Okay, see what we get. Could not load, oh, sound background.mid. All right, I'm going to copy a copy of Space Nuts off of the sampler disk. I'm going to try and do this on its side. And I'm going to throw Compton's Multimedia Encyclopedia around while I'm at it. And try my best not to wreck my sampler disc. I have another one, but it's rather hideously scratched. There we go. All right, I'm going to follow you in. Yes. All right. All right. Do you call in? Okay, I think. Space Nut. I'm a dummy. There we go. No subdirectories, right? This one, I have to scroll far, so I don't care. Cool. All right. All right, now I get to watch me copy files. Okay, let's get this out of here. Actually, some drives do have little lips to run sideways. This seems to be one of them. I know about half of YouTube is yelling at their screens, and what an idiot I am for doing that, but hey, my computer, not yours. Okay, let's try this one more time. Okay. Ooh, we have audio? Oh. Now I don't. Oof. That is absolutely horrid. Huh. Okay, it kind of works, but if you heard that sound, it's still doing it. I mean, these cards are old. I don't even know if they... I'm going to do something I really shouldn't, but... Okay. It's doing it on the line out as well. I wonder if we're having interrupt or DMA troubles. You know what we're going to do? We're going to turn that off just for the sake of my own edification. The synth doesn't even have an interrupt set. Oh, that's interesting. I'm going to use DMA 5. Right? Let's see here. Where's my pick in case I need it? Maybe I can get these off without... All right, that's 5. I'm going to power that up, and we're just going to boot it without the drivers or anything. I don't really care about the high memory or anything. Space Nuts doesn't care. So we're just going to F5 our way to a faster startup. Now I have to remember that I'm using DMA 5 for the card when I start GBIOS. It does find the audio card, and it does kind of work, but weird. Okay. Okay. Okay, the interrupt is still 7. Is now 5. Okay. Okay, let's see what we get. Now we're getting a high-pitched squeal. All right, let's see what it does when it gets to the... I'm gonna have to wait for it. I don't know who these people are on the high scores list. Are we alive? Oh, we are most certainly not alive. Okay, the machine is probably dead, right? Okay, powering back up. I set this back to IRQ7. It occurred to me that I might be an idiot. I gotta be careful tapping that. There are 2 jumper settings. I mentioned this when we were taking a close look at the cards for the DMA channels. And one may very well be, they were both set the same when I got the cards. I left them that way. But one may very well be for the synth and one for waveform. So I set those to different channels. Now, one's back on 7. The other is still on 5. Let's do this. GBIOS. And they want the wave table. So WI equals 7. WD equals, which one did I do here? I'll call it 6. I think I did 6 for the wave table if they're in the same order. So if you remember back to the cards, the IRQs, the jumper order was wave on the left, synth on the right. So I'm going to take it and hope that it's the same. If not, I'll just switch them around, but AC nut. And again, there's no dock for these cards, so there's no M to R to the F, right? Okay, here we go. Ooh. That is the audio card working. It's a little crackly, but you're getting the synthesizer services are working. The wavetable's a little funky. Just to okay. It seems to be working. Now, there's no interrupt configured for the synth. Probably set one. For now, I'll leave it. The card seems to be working and the synth seems to be working. So, again, I have no idea if they're required or not. Typically, sound hardware does use interrupts, so it's a little interesting. But again, these cards are undocumented enigmas, friends. So, but we have, actually, what you're looking at now is, except for the hand control, a functional VIS and a PC. Now, this is a 486 100 megahertz PC, so this is the single most overpowered VIS in the history of VISing, but it does, in fact, work. It looks like total ass on the television. I guess if I really wanted to, I'd have to write something to see if I could call the int15 service. I think there's an int15. If not, there might be an int10 call to set the video up for interlaced video modes. So that might be something I have to do on another machine, like on the 3000 or somewhere else. Sweet. And just do that. I'm interested in the game. This has a pretty... And it just crashed. All right. Will it run again? It even went back to the root directory. That's interesting. Here, run again. Makes a... I mean, it does make a noise when it displays the title screen on the real VIS. Cool. Okay, I guess that leaves us the hand control. And for what it's worth, I mean, I should point out, this is the first time, I mean, the Save It card we used a while back, and the video card really, this is its first use beyond me sticking it in this machine once to see if it actually worked. This is the first time these cards have been used together in probably 30 years in tandem, right? That's pretty damn cool. We have a desktop VIS development system, sans the hand control, and yeah, that's pretty cool. The cards work-ish. I should point out, too, these are early dev cards. The ROMs, the GALs, all that stuff is mid-92, so the VIS was still in development at the time. There was a lot changing. The BIOS was still changing all the way up through October of 92. They were still doing a lot of final updates on the BIOS and stuff. The video BIOS is really early, so there's, you expect some kinks. You expect things to not be perfect, and it's not going to perfectly emulate a VIS. But the whole idea here was you could test your calls, your VIS hardware and software calls, and get some playability testing for your title on a PC without having to have a VIS in hand yet. You might have the cards, but not a VIS in hand. Or you might have multiple people working, 17 VISs. You don't want to deal with a serial loader card. Or if you don't have that, then you have to press a disk every time you want to test. And speaking from experience, that process sucks. Even in the age of modern CDRs, where I can just burn a disk, it still really sucks because you end up making a ton of coasters and throwing them away. And it is, unfortunately, the state of dev for VIS. I don't know. Every so often, there's a little bit of talk about recreating the serial debug card, but that's well above my skill level, friends. Crashed again. And quite frankly, I wouldn't ask anybody else to do it because the audience for this thing is so damn small. I mean, hell, take a look at the view counts on these videos, friends. the interested audience in this just makes the bullshit to gratification ratio for developing a card, even if it's easy for someone who does that for a living, seems to be a bit of a stretch. Same thing with these. These cards aren't getting reproed. There's a lot of Tandy-specific VLSI on them, and I mean, the gals and stuff can probably be read. The ones on the video card, let me read them. But for who, right? It's mostly a PC, and I hate to say it because it's not the best thing for, you know, trees and fish and plastic in the oceans, but you can make coasters, unfortunately. It's pretty much the way it has to be. But these cards are darn cool, and I'm going to see what else we can get to run on them, shall we? So one more thing. Let's take a quick look at the IR controller. I'm going to see if I can figure out where that clock line goes. I'm going to do that off camera, or if there's a clock line. I've got to map out the clock line on the PS2 port and see where that runs, because that might give me a clue as to whether or not it is a PS2 port or not. And I mean, if it's connected, if it's not connected to anything, then I have my answer. It's probably an IR bulb. But I'm going to bet that it's a PS2 style port, and then I'm not going to just be able to wire up a receiver diode onto it. So I'm going to take a quick look at the IR card, and we'll come back. All right, folks, you're going to have to excuse the crudity of my work area here and my reuse of my 4833 as a bench. But that's what we're going to work with. I'm not screwing with the cameras. Okay, so I have here the IR receiver card with the wire sticking out of it, of course. And actually, that wire is sticking out in a very opportune place. So if I can get this down low enough for the camera, we'll focus on it. This here is pin 5. And if I take a look at a PS2 pinout, like you are now on your screen, pin 5 should be the clock. Okay? So it turns out I'm going to use my meter here and see where it goes. I think, judging by the connector, it should be on this side somewhere, one of these guys. If it's attached to this resistor, that's going to be a bit of a problem, because that means it'll be a clock line that's pulled up somewhere, because typically, a lot of times on PS2 ports, the clock and data lines have pull-ups on them. So this is a ground, so it's not grounded. I'm going to go on the other side of this resistor. Ooh, nothing. Okay, there we go. I know some of you hate the beeping, but my room, my noises, folks. Okay, so it's this here. It's this pin right here, which I don't know if you can see that on the camera or not, but it doesn't go anywhere. And if I flip the board around, it would be right about here, and there's nothing coming out of the card. So I'm going to off camera just do a cursory touch on some of the neighboring ICs and such, just to make sure that I don't get hit. But judging by the way this is and the fact that that's just soldered to the board and has nothing, and these other ones do have traces, like here I've got the traces coming off the resistor and going over to that Z8 controller that we talked about before. So that is a little bit of fun. That actually does lead some credence to my theory that you could drive an IR receiver diode with the board. So I'm going to quickly double check my work on the clock and jot down those pinouts, and then I think we're going to try this out. I'm emboldened enough, and a photodiode shouldn't do any damage. Worst case, I'll probably just wreck the stupid diode. We're going to do this for science, and I'm going to pray to the God of Charles D. Tandy and everything else holy, that I don't screw this card up, because if I do, I'm going to be very, very unhappy with myself. All right, but I think we're good. Let's do this. Now then, I spent some time with the IR receiver card and the multimeter to figure out the pinout of the PS2-looking jacks on the back, and it turns out my assumption is correct. It is not PS2. So you can see I've got some rather precarious-looking handiwork attached to the back of the case with some vinyl tape, and that's because I was correct that pin 5 is not a clock and there are no PS2 signals here. All this really has is 5 volts, ground, a data line, and that resistor on the back of the board is a pull-up that goes nowhere, the idea being that you could use that pull-up in your application if you wanted. Now technically this diode wants a 30K resistor. This is 10 that's on the board. I'm going to say it's going to work, and I have 4 more if it blows it up. And the nice thing is, because that resistor is take it or leave it, they didn't wire it in for me, I don't have to use the onboard pull-up. I can use my own if I want. And maybe that's why that's like that. I don't know. I didn't design the hardware. But it is ready to go and try out. So I'm going to go back over here, VIS and G21, and I'm going to admit I jumped the gun and just friggin' tried it, friends, because I had to. So now we have to tell GBIOS the interrupt for the hand control in addition to the interrupt and DMA for the wavetable. So we're going to do that. And that's going to be /hi, I believe. Let me double check my doc here. hi equals 3. This is wi equals 7. wd equals 6. Okay, now you might remember if you've been watching the series from the beginning that I did a whole thing on the hand control and I talked about development with it, and I actually demonstrated my stupid VIS control program that I wrote to draw a triangle on the screen and allow me to move it with a hand control. So we're going to demonstrate that. Okay, so I have my VIS hand control here, player selection set to solo, and I have that taped to the back of the machine because obviously IR needs line of sight, and I'm just going to run VIS CTRL. And lo and behold, I've got my triangle, and if I move the controller, it works. So it turns out it was correct. The card is wired or configured specifically for whatever photodiode you want to use. They give you the pull-up to pull the data line up if you need to, as this photodiode does. You can see with the data sheet, probably sitting on the screen somewhere now, that this thing has, you know, just 3 pins on it, and it wants you to pull up the data line. And that seems to be working very well. And even though it's a 10K, not a 30K resistor, it seems to be not interfering with the controller's operation at all. The thing works perfectly fine. As you can see when I wrote this, I didn't do a good job cleaning up from the bottom of the triangle when I moved it. But who cares? It was just to demonstrate the point. And it works again to demonstrate this point. So now we have the entire functioning VIS dev card set up for the first time in probably 33 or 34 years. The cards all work. The audio is the only one that's a little sketchy. The video is odd, but an odd BIOS. And I think I'm going to want to try and take a look and see if I can find out if there's interlace settings I can do. Maybe the old video BIOS just doesn't default to dealing with regular CRT displays. So with that in mind, let's see now if I can play Commander Keen and Keen Dreams, because I couldn't play it before because the hand control didn't work, and I ripped out the keyboard code for the hand control. And want to do it in addition. So I don't need any extended memory or anything like that, so I'm just going to give her the old F5, and we're going to GBIOS, so HI equals 3, WI equals 7, WD equals 6. Okay, and I believe Keen Dev, I've been moving things around because I've been working on trying to finally get the source code up on GitHub. I only promised it like 3 months ago or more. Okay, K Dreams, this should work. Good, okay, I see the gameplay, and if I push a button, hey, look at this. Oh my goodness, this is neat. I can't believe this. All right, now, oh, I don't have the speakers hooked up, do I? Yes, I do, okay. Will I get sound? Yep, the ad-lib audio just played the sound effect. It did. You might be able to hear it. It's really hard to play on this television. The video is a little interference here and there. I say interference, a little bit of, I'm out of balls. Gotta hold it up because, wow, I can't believe it. There's a little bit of, video glitchiness there, and I've noticed that on the card earlier when I was playing Space Nuts too. So let's see if I can get this mofo. Yeah, I show you. This is damn cool. So I'm literally sucking at this game. I'm literally playing a VIS program I wrote on the VIS dev cards using a VIS hand control, VIS sound, VIS video, everything. This doesn't use the Save It card, so that one's kind of left out of the party for now. But this is interesting, and now this puts us in a position where I can probably try some additional VIS software on this. And I think that's something we're going to want to do. I think for now, I'm going to see if I can do it with the CD-ROM drive to see how I can deal with that. I know there's some redirection that can be done, I'm pretty sure, so that I can use VIS utilities with this correctly, because the VIS utilities are going to expect the A drive. They're going to expect the CD-ROM to be on A and all that other good stuff. So that's going to kind of be a little bit of a next step for us. That said, this is actually a little longer than I imagined it going. So yeah, that's pretty effing cool. I think we're going to have to revisit again to actually try some different software on there now that these cards are installed. But given where we are, I think this is a good place to call it for now. Well, folks, I think this is a good place to call it, don't you? We have successfully verified that these cards are in some functional state. Not perfect, of course. The video has a little bit of artifacting in places. I don't know if that's video RAM. I don't know if it's just the old BIOS, bus timing on this machine. Don't really know. They're not my cards to mess with, really, and try and modify or anything, so I'm not going to go crazy trying to diagnose them or anything. They function. That was the point, to just explore them. And quite frankly, it might just come down to ID10T errors and me not knowing what I'm doing with these cards, so I have no reference. But the cards all work, and this is for the first time in probably 35 years or so, 34 years, that they've all been together, seen power, and have actually acted as a VIS development system. So that is really effing cool. They all seem to work very well. Again, the audio's a little janky, but then again, Space Nuts didn't sound great, but the Keen Dream sound effects sounded just fine. So it might just be the way Space Nuts sounds. I forget. I'm going to have to actually play it on the VIS now and double check. But honestly, I couldn't be more happy. And I'm super excited that the IR receiver card was just a simple photodiode wire in, and I didn't have to do any weirdness. It wasn't a PS2 interface. That was a really cool find, and I'm glad I took the chance on plugging in the IR receiver diode. That was just awesome. So next time around, like I said, this is going to be the last of the mainline branded series. The next ones I'm going to stop doing the intro just because this was the core of it. We've walked through the entire VIS platform at this point from end to end. I don't think you're going to find a more comprehensive place anywhere on YouTube or, quite frankly, anywhere else on the internet than here. So it's been a whole lot of fun to get to touch something that almost nobody does, to experience the back of the house, and to kind of see inside, kind of almost inside the minds of some of the developers, some of their comments, some of their documentation. Source code comments have been hilarious. Find out how this platform works, how it is and is not like a regular DOS machine, and what makes it special, what it's like to work for it, the different ways to get software to and from it back in the dev days, and really connect with something that is probably the closest I'll ever get to Tandy engineering in the back of the house. So this has just been really cool. I think our next step for this, I am going to continue playing with these cards. I think we're going to try and run some real VIS software on there, maybe something from disk. Maybe I'll get that stupid owl demo to work with the dumb Flappy Bird in his cage and see if we can get him up and running on this thing. And I might even see if I can take a crack at making modular Windows run on the Tandy dev cards, because there's hand-controlled DLLs, there's the Gryphon video driver files, all that stuff. So I should be able to get my modular Windows install to fire up on these cards. So that's going to do it. I'm TJB Chris. Thank you so much for joining me. I will see you next time.